Hi, this is Mrs. Tratner for Physical Science. The lesson that we're going to go over today is wave properties. I'll be doing the check-in question in class, so we'll go ahead and go on to the objectives. These are the objectives that we're covering in the unit. The goals for today is to identify characteristics of waves, look at the relationship between wavelength and frequency, and calculate frequency. So what I'm going to do is I'm going to go over some basic things about waves and show you how to calculate frequency. And then in class, we are going to do a virtual lab. So we will do the review questions in class. So these are some notes that you should take about waves. So when we looked at waves the other day, we talked about what waves are and how waves transfer energy. Well, waves have certain properties, and we're talking about mechanical waves. They have amplitude, they have a wave length, they have a frequency that's measured in hertz, and they have a speed. So waves travel at certain speeds depending on the medium that they're traveling through. So not only will a wave travel at a certain speed during through a particular medium, but we can measure how far the wave travels over a period of time. And we can calculate the speed of that particular wave by taking the wavelength times the frequency. So what does that look like? Well, if we wanted to actually calculate the speed of the wave, you take the wavelength times the frequency. So if we had this situation where a wave has a wavelength of 3 centimeters and a frequency of 5 hertz, we can calculate how fast that wave is traveling by taking the wavelength of 3 centimeters and multiplying it by its frequency of 5 hertz, and that gives us a speed of 5 centimeters per second. Now, we could also, if we know the wave's speed and we know the wavelength, we could calculate the wave's frequency. So we know that the frequency is the number of complete waves that pass a given point over a period of time. So if we start with point A to point B, we can see how many complete waves there are from point A to point B. So if the medium doesn't change, the speed of the wave will be constant. If the wave frequency increases, then the wavelength will decrease. And we're going to look at this in the virtual lab. But how could we calculate, how could we find the frequency of a wave? Well, we can do that mathematically. If we have the speed and we have the wavelength, okay, and we have this situation, the speed of a wave on a rope is 10 centimeters per second, and its wavelength is 2 centimeters. To find the frequency, we would take the speed and divide it by the wavelength. So you would take 10 centimeters per second and divide it by 2, and we would get 5 hertz. Okay, so if you know certain parts of the wave, then we can calculate either the frequency, the speed, or the wavelength. So here's another example of being able to calculate frequency. The speed of a wave on a violin string is 130 centimeters per second, and its wavelength is 5 centimeters. What is its frequency? Well, you take the speed of 130 centimeters per second and you divide it by 5 centimeters. The frequency would be 26 hertz. Now, just to kind of refresh our memory in terms of the different parts of a wave, okay? So you have the line of origin where that wave starts. You have the crest, which is the top part of the wave. You have the trough, which is the bottom part of the wave. And you can see the complete waves in this illustration. So what we're going to do in class is we're going to look at some characteristics of waves, and we're going to follow the procedure in the lab and answer questions on the whiteboard. What we do in class will be graded, so everybody needs to participate and contribute to the answers on the whiteboard. And I'll be going through that in class. But it's important for you to have watched this recorded lesson so you understand how to calculate frequency, how to calculate speed.